Welcome to Spring LIB.
Okay, so we're doing chapter 29, problem 59. So in this problem, we have a rod that is on the axis here. So it's free to rotate upwards, and it is actually in motion upwards right now. And the rod is a length L, and it's all in a magnetic field that is out of the page. Okay, cool. So what we want to do is find what the induced EMF is on this page, on this rod. So to do this, we're going to have to use this expression here, which is that the dE is V cross B dotted into dL of the rod. Okay, so this is pretty simple because we can just do V times B dr because we can just all work in the radial direction here. And we can also know that that V is the same as omega times R. So this is B omega R dr. Cool. So now if we're looking for the total EMF, we integrate the differential, which is the same as integrating with respect to R from 0 to L over the whole distance of the rod. Omega times B times R dr. Cool. So if we integrate this, we get 1/2 omega B R squared evaluated from 0 to L, and that becomes 1/2 omega B L squared. If we plug in our values for this, they tell us some of this stuff. They tell us omega is 8.8 radians per second. They tell us B is 0.65 teslas, and L is 0.24 meters. So we can plug all that in, and we see this comes out to an induced EMF of 0.165 volts. Cool. So now part B is asking what's the potential difference between the ends of the rod. So this is just a rod. There's no circuit here. So that means there's no current flowing. We just have one charge is pushed one way and the other charge is pushed the other way, right? So there's no current flowing. So the only potential difference is the exact EMF. So the potential difference equals EMF equals 0.165 volts. Cool. So now for part C, it's asking us to imagine that instead of the axis on the end, we're going to put the axis free to rotate the rod in the middle. So this is L over 2 on one side, L over 2 on the other. This side would move upwards with V, and this side would move downwards with V. Okay? So now the only difference in our EMF equations, so EMF for the right side would be just 1/2 omega B, but instead of L squared, we have L over 2 squared, which becomes 0.165 volts divided by 4. It becomes a fourth of what it was before. And the EMF for the left side is exactly the same, but it's in the opposite direction. So these are going to cancel each other out. So that means the EMF net is 0. There's no EMF netted on this because each EMF is going to be in the opposite direction. They're going to be pushing the charges in the other direction, so they're just going to cancel each other out like neither one was there. Perfect.